video for Lab 1 for Physics 114, an analysis of basic types of motion. Today we will be talking about 3 different types of motion: uniform motion, slowing down, and speeding up. These types of motion are very common in the world around us, and so this lab's purpose is to show them and talk about them. Material used in this lab are Logger Pro on a computer, videos of a toy car and a ball toss, a basketball, and a toy car. How I performed the original lab was using Logger Pro on the school computers and inserting a video into Logger Pro, and then plotting, setting the scale and setting the origin, and then plotting points on the video as the object in discussion moved. Then I picked the graphs that were necessary for the different types of movement and screen capped them so that we could discuss them. The question that we're going to be talking about today is, what is the difference graphically and physically between the different types of motion of uniform, slowing down, and speeding up? Logger Pro, which is the software that we use to make graphs using videos so that we can analyze it for this lab. This is the program. So to start off, you will click Insert up here and insert a movie. You can click on Insert Movie. The ones that come with the program pop up here, which we can also use, but I'm going to go ahead and use one that Professor posted on Canvas, which will be under Downloads, and I'm going to start with the Away and Towards, and here's the video. Just take a second to load. And so we have the video of the toy car. Now, we start off by setting the origin, which will be this kind of green button with an arrow, and I'm going to go ahead and select the car right here, and there we have created our origin. And then now we're going to set the scale, which is this sideways or horizontal ruler. And I'm going to go from here to here, which is 1 meter. This just gives a accurate measure and scale for the graph. Again, this is just make sure this is what you wanted to do, so I'll say OK, and then I can start plotting. So I'm going to grab the kind of red dot target, and I'm going to start dotting on the car, and the car moves. And that is the end of the video. And so because this is the end of the video, we can go ahead and click out, and we have our diagram here. So I'm going to go ahead and make this scale just a little bit. Oh, right. I'm going to show the scale here. So we have the beginning of the video. As you can see, this red is X and the blue is Y, and it's going to go up, kind of stop off. This is the quick stop you can see here, and then it slows back down. Now, to show this, we are going to use the, sorry, wrong, what's this? Okay, so I'm going to go ahead and go from here. I'm going to go and hit select, so it's going to be about here to about here. And we're going to add a line. Go ahead and say add that line there. Okay, and there you go. You got the slopes for each of the parts of the slope. Now, because this is uniform motion, this slope works, this is the slope for all of this motion. This is the slope for the quick stop, and this is the slope for all of the going back motion. This motion of this part of the graph is also in a negative direction because it's going back towards the origin. So as we saw in the video, let me go ahead and bring this to move this to back. So in this video, you could see that the car came from this area, moved forward, quick stop back towards the origin. So as I set the origin here, means that when it's going back, it will be going in a negative y, or x, sorry, negative x. And you can see because the car is not moving up or down, the x or y here, the y is flat. Now we can look at x velocity. That's going to be our other graph to look at. So here we are looking at the velocity time graph for the car video. And as we can see, the velocity is at 0 as the car is on top, and as it is stopped, and as it speeds up, the velocity slowly goes up and up and up, reaching max velocity. Then it slowly goes back down and reaches 0 at the point where the car reaches this point where it's a quick stop here. Then it goes down back, and it reaches the max of the reaches the max of the backward motion, and then it slows back down. Now, the reason that this velocity here is in a negative direction is because again, just like the velocity position or the position time graph, the car is moving back towards the origin in a negative direction, and therefore the velocity here is negative. Yeah, this is the video, again downloaded from PHYS, and I'm going to do the same methods I did, which will be setting the origin and things like that. Then I'm going to go ahead and plot the point, and I will be right back. Okay, now I have the graph of position and time for the ball toss. As you can see in the last one, the blue, aka which represents the y, as you can see over here, y in form of meters. We can see this is now it was flat before because the object was moving along the horizontal axis, not moving vertically. But now the object is not moving vertically or horizontally, but vertically, and so the y is the increasing. Now, so as we can see, this increases, but unlike the car, we have a non-uniform motion of increasing. As the ball goes up, it starts to slow down, which is represented by how the dots get closer. And if we would draw velocity vectors here, we could see the velocity vectors getting smaller and smaller until it reaches 0, v equals 0 at this, or approximately 0 at this top point, before it goes back down. Now we can also see that as it goes back down, the velocity vectors would start to get bigger and bigger and bigger, and the area between these dots gets bigger, and it reaches maximum velocity. So it would reach maximum velocity before hitting the hands, which is about at this point, because as you saw a little bit previous, there was some glitching with my video, but it's going to be it would be slowly increasing, and the max velocity of the ball during this movement is right before it hits the woman's hands. So again, this is the process of speeding up, this section of the graph is the speeding up process. This section of the graph here is the velocity equaling approximately 0. And then this section of the graph here is the speeding up, back going down of the graph, or of the ball, speeding up and eventually hitting the hands and being stopped. Now, the reason that the graph goes again negative back towards the origin is because the origin is the ball sitting in the woman's hands. It goes up away from the origin and then back down towards the origin, so it would be going back down on the graph towards 0, aka the origin. Now to look at the y velocity graph, so because this is moving in the y direction, or vertically along the y-axis, we will be looking at the y velocity instead of the x velocity. So again, like I did last time, I'm just going to go ahead and shrink just so we can get a little bit better of a picture here. Now, this may look similar to the previous velocity, but we can see the differences if you look a little bit. Look into it. Let me just adjust it a little bit here. So, kind of adjusted it pretty small over here on the position, but the velocity is 0 as it leaves the hands of the woman. It reaches a point where it's max velocity. It's going and going, and you can kind of, so it's going pretty fast at the point of this area along the graph is showing the point of launching off out of the hands of the woman. Before it starts to slow down, it will hit 0 about at this point. It will reach 0, which is when it hits the top of the motion, and then it goes back down. It's speeding up, and before it hits again, like I said, it is this fastest motions here are right before it hits the woman's hands. Now the velocity, as you can see, we can go ahead and move it out. Go ahead and expand it. Just get this adjusted here. We can go ahead and see a little bit more detail. So it goes back down, goes up in the positive along the y velocity, and then it goes negative, similarly to why the x velocity graph on the car video went negative was because, again, it's going back towards the origin and therefore is a negative velocity. Compare and contrast of the different types of motion. Now these graphs here I have set up, which is the position time graph for the car video and for the ball toss. These may look different than the ones I just made. This is because these are ones created in class, and this ball toss is actually using a different ball toss video, but the same idea, a basket or a ball being thrown in the air. And this is a little bit more of a detailed and more precise graph for the car video, which is very nice to look at, better than the quick one I did for explanation, just because it shows that gradual increase in x, but the constant kind of motion, or the uniform motion that we see going here in the quick stop here and everything. So I'm going to go ahead and show this one, and as I explained, this is a uniform motion. The car reaches a quick stop and then it goes back down towards the origin. Now we can see in this one here, let me pull it up here. This is the one for the ball toss. Again, this looks just a tad different than the one I just did, but we can see how this is kind of this. There's a large gap here, kind of a little bit smaller, a little bit smaller, smaller, until it reaches 0. So a big kind of thing we can see with the slowing down, speeding up of the ball or the ball toss is that yes, it definitely has that definitely has that kind of bell shape. Looks pretty uniform, but we can see as this goes back down, it starts to slow and very. Can you see? And let's see if we can pull them both up. See this kind of the contrast between the even space between each of these ones. He's kind of a little smaller here. Just this is the 0, where it's the quick stop, versus this where it's quite a large gap, as it kind of starts to slow down. The velocity vectors, again, we would see them get smaller and smaller, whereas here they would be even. Now, there obviously, as you can tell, is definitely some certain amount of human error, machine error, things like this. But this is just a graph to show the theory of kind of how it works. So, there are points probably along this graph here that these are smaller or bigger than each other. Again, there are errors involved, including human error and things of that sort.
In today's lab, I have shown the procedure for setting up the graphs on Logger Pro and discussed about what each one represents, what each section of the graph is, and the comparison between the two. So we've just talked about uniform and non-uniform motions. Now, what are the main differences between these two? Big one is that V is constant in uniform motion, and V is not constant in non-uniform motion. Another one is that, as seen in a graph earlier in this video, there is a slope on the movement of the car going to the right, its quick stop, and it going to back towards 0, or the origin. Now, these 3 slopes show these 3 times in the motion of the car. This graph here being this motion here, and this graph here being this motion here, and finally this top one being this quick stop right here. However, in V, you cannot just solely write 3 slopes because V is not constant. That means that it's always changing, and therefore we can't have only 3 slopes. That's not possible. So that is not something we can do. So as I kind of drew here roughly, you have different angles, different slopes at about each point or so. Now, these are some of the main differences between non-uniform and uniform motions. And there are many more that we will study in this physics course, but I hope that this was a good look into the basic types of motion, that is uniform, non-uniform, speeding up, and slowing down. Thanks for watching.